In this video, we'll be exploring significant figures and scientific notation and what they mean and what their purpose is in math. So firstly, we have significant figures, and it's important to note that significant figures are the number of digits that indicate its accuracy. It's also important to remember that we start counting significant figures at the first non-zero digit. In the first example, we have round to one significant figure. Using this number, we look at the first non-zero digit, which is 4 in this case. We look to its right, and we have to round up because it's over 5. So here we have 500,000. Alright, the second part of this example, round to 4 significant figures. So it's basically the same, but we just count 4 digits after the first non-zero digit. So 1, 2, 3, 4. It's at 2. We look to its right, which is 7. So we round up, so 4, 8, 9, 3, 0, 0. Alright, we move on to this decimal, which is a bit harder to remember than whole numbers. So with this, the first non-zero digit is 3. See how these first 4 digits are zeros? So our first non-zero digit is 3. So we'd round that to 0.0003. 4 significant figures, same concept as before. So we do 0.0003. 1, 2, 3, 4. Look to its right, it's 2, 2, 7, 8. And we leave it at that. Alright, we'll move on to scientific notation now. So this is just a formula that you'd like to use, which A represents any number between 1 and 10, and the n must be a whole number. So this n, the power, must be a whole number. So basically, this shortens the number in order to keep the same value without having to write any other numbers. So it's just like before. So we'll move on to the examples. Convert to scientific notation. So in this, we look at the first digit, and 45 is not between 1 and 10, so we have to do 4.5 times 10 to the power of n, which in this case n represents the amount of zeros. 1, 2, 3, 4, 5, 6. So it would be 4.5 times 10 to the power of 6. Decimals is a bit trickier. It's the same concept, but instead of the whole number of n being positive, it is negative. So we look at 3, 4, 5 first. 3.45 would be in between 1 and 10. And we times that by 10 to the power of n, and in this case the n is 1, 2, 3, 4, 5, 6. So negative 6 as well. Negative 6. Alright, in this next example, we want to expand the scientific notation. So here we got 7.348 times 5, times 10 to the power of 5, sorry. And that we just do 7.7348, and 5 is the number zeros, so we just put 1, 2, 3, 4, 5. And that's our number when expanding. Same concept as before. So in this case, it's just negative 7. So the negative represents the decimal. So 1, 2, 3, 4, 5, 6, 7, and 3, 4, 3. And yeah, so that's basically scientific notation and significant figures. Thank you.